you everyone for coming to this presentation. So we're going to talk about how to build what we call a search as you type user experience. And hopefully, yeah, we'll try to do a live demo that will work in the 15 minutes just at the end of this session. So first of all, my name is Tim Carry. I'm a developer advocate at Algolia, and I will be doing this presentation with Alex.
And I'm Alexander Collin, and I'm a solution engineer at Algolia.
So just a bit about what we're going to talk about. We'll start with a small introduction explaining what we do exactly at Algolia, and then we'll dive a bit more deeper into the three core components of what makes a great search user experience. Then we'll go into the code and make it actually work, and we'll still have some time for some question at the end. So first of all, about who we are, I would like to know who in this room already knows about Algolia. Okay, few people, so it's worth explaining. So we are a hosted search API. It means we are a SaaS product. You push your data to our API in JSON format. We index it, and then you can just send a few keywords to the API, and we will return the most relevant result in just a few milliseconds. We handle typo tolerance, plural, synonyms, and we build that with core focus on these 3 points. The first is what we're going to talk about today, a great search user experience. It means that you want your end users on your website to not be frustrated by your search. You want them to find what they are looking for directly and not search being a point of frustration. So we went to great lengths to help you achieve that. The second point is the ease of integration. We are an API, we are a tech company, we're all developers. We take great pride in our documentation, tutorial, guides, SDK in every language to help you use Algolia, whatever the language you are coding. And the last one is our strong infrastructure. We are highly reliable, so you can just push any data and search on our service. We will take care of everything, and it will just work whatever you do with it. So just a few numbers to give you some perspective about Algolia and what it means in terms of numbers. We today have more than 2,000 customers in more than 100 countries. It means more than about 30 billion write operations per month and 15 billion user-generated queries per month. What we mean by user-generated queries is a search done by your end user. You might have already used us without knowing it if you ever search on Hacker News, Periscope, Medium, or Twitch. And I will now let Alex talk about why search is key for a great user experience.
Yeah, so what we've seen is that multiple people for decades have searched what is the best way for people to access in a meaningful way to content. People have been trying to do smart navigation, directories, and so on. But at the end of the day, we see that search is still the best and the easiest way for the end user to access to the content. Think about Spotify, LinkedIn, or Amazon. Whatever you're looking for, a song, a person, or a product, what you want is to get the relevant results with just a few keystrokes. And that, of course, applies to them, but not only. It applies to any web app or mobile application that deals with any type of data. Can it be products, places, venue, hotels, documentation, photos, and so on, and any type of application that you guys are probably building. So yeah, search is key. And what is key in search is those 3 ingredients. To have a great search, you need to have a search which provides relevant results with a great speed and easy to use. And that's the last part, usability. Once you have those 3, you can say that you have a great search experience, and that great search experience will bring you, will have a beneficial impact on your business. So we see through our customer that the one who implement a great search experience see an increase of the website usage. Of course, if the user enjoy more using the website or the application, they will be more likely to go back to that one and consume more. Also, a decrease of no-result pages, which results in a lower bounce rate. People have been investing lots of money on getting users on their website. It's a shame to lose them. So having less no-result pages actually help a lot. And also, we see that it improves a lot the branding and the customer loyalty. A customer, an end user who is happy will probably tell his friend. It will bring more users and so on. So what we see at the end is having a great search experience improves revenue. Can it be increase in sales, in direct revenue, or indirect revenue through ads? So let's dig into those three aspects. So relevance, what matters in relevance. Here we went on EMDB and we took a small screencast to show that we were searching for Arnold Schwarzenegger, and unfortunately we see that even on EMDB we couldn't find the right person because we missed the C at the beginning and then we missed the W. So the engine, unfortunately, wasn't able to understand the user who made some mistakes. And making mistakes is actually something quite common. Google has published some studies where they show the different ways people have searched for Britney Spears. We have Britney Spears. So making mistakes is super common, either because you type super fast on your keyboard or because you're on mobile, and it's even more the case with the fat finger effect. So to have a great search experience, your search engine needs to understand the user that make typos and mistakes. That's a must-have, and that falls into the relevance part. Of course, relevance is also a lot about textual relevance, but it's also a lot about business relevance. If you can provide an engine, a search experience where just typing a few keystrokes, you can return the popular results. Like here, Breaking Bad. Breaking Bad is first, just typing B, because the engine uses the number of followers, and the most follow is a TV show or a movie, the more likely that one will be on the top of the list. And we can think that if a lot of users like Breaking Bad, just typing B, I may be looking for Breaking Bad. And more specific I get with my query, the more chance I have to find the results I was looking for. So what is important here is textual relevance, but also business relevance. And of course, it's not just because of the number of, it's not just the number of time a word appear in the object you search for, which matters. Here we're searching for iPhone. The first product is a case for iPhone, and the word is repeated multiple times. Second one is an iPhone. Here, what we're looking for is the second one, probably iPhone 6s, and not the one with the word iPhone repeated 5 times. So what matters is really the position of the keyword and not much how many times that keywords appear in the object. For speed?
Thanks. We've seen for relevance how it is important, but now we'll see how speed impacts the overall user experience. We took the example of Medium.com. Medium, they have really great relevance, and they have a nice UI as well. When the results are displayed, you can see a lot of information about them, but it's really slow. Medium is actually one of our customers, but they decided to use a backend implementation. It means every time the user is typing a character in the search bar, it goes to their backend, then through our infrastructure, back to their backend, and back to the end users. It's a lot of unnecessary round trips, and you're losing a lot of time just in the latency to get the request from one point to another. So what we usually advocate people to do is to do this kind of as-you-type search, meaning, like Alex was saying, even from the first keystroke, you can display a relevant result. They won't be the most relevant. They will get more and more relevant, more characters you're typing, but we see that people usually find what they're looking for after 3 or 4 characters. And you do not have to wait to have one complete word, and you especially do not have to wait for people to press enter to display the results. You also need to be careful about providing this kind of experience to everyone all around the globe. It's not because your main server is located, let's say, in London, but your users are in India, that they could not have the same search speed. What we did for that is what we've called the DSN, which is the Distributed Search Network. It means that we have data center all around the world, and when you open an account, you pick which one is your primary one, and every data you will push to that primary data center will be automatically replicated to the secondary one you've picked. So we do a system based on geolocation, based on IP. And so end users really searching on your app or website will target the closest data center from where they are. And oops, you have a meeting. Okay, so not even in the live coding session.
And I close everything.
So yeah, we have 15 regions all around the world. You pick any one of them, we will replicate automatically the data. You just have to pick the main server as being the one that's maybe closest to your development team, so when they are pushing data, it will be as fast as possible, and we'll take care of replicating everything everywhere. Now, that was for speed, and you saw how speed is important, and we'll finish with the UI usability by taking the example of Livestream. Livestream, they have a great relevance in what they are displaying. It's also displayed really fast, but they decided to display it in this tiny drop-down where you cannot see much of the content, even if they have really interesting display on the main page. So you have to take care of that, and you can actually do what one of our customers, Birchbox, it's the French version of Birchbox, they are selling cosmetics. They decided to go with the mega drop-down, where you search in product, in categories, in blog articles, everywhere. Actually, your users, they have no idea where what they are looking for is located on your website. And they want to search in everything, and you have to display results coming from everywhere. They do not have to know how you internally categorize things. So this is really nice because they're not exactly sure what they're looking for, but they will find it. So we've seen how these three components are really important, and if one is not here, the whole search experience is off. But if you manage to get all three of them, you will have a really great search experience that your users will remember, and they will remember that it was fast, that it was easy to find stuff, and they just had to type a few letters to find what they were looking for. You cannot remove one of them. You need the three of them. And that's what all the theoretical part. So now we'll put that to the test with some real code and make that work, hopefully if the Wi-Fi is with us, on a real website.
Yes, we have Wi-Fi since I got my calendar.
Yeah, right.
All right, so where's the mouse? It doesn't move. All right, cool. So I think I still have a few more slides, maybe.
Explaining which website we're going to
Yeah, exactly. Improve. So live coding. So let's build it. So basically what we did is we took the Smashing Magazine website and we realized that search is great but could be better. So here's a use case, an example where we only get relevance. We don't have any as-you-type experience, and the user experience itself is okay, but it could be better. So we will redo it together. And what we want to achieve is that kind of experience where the design is consistent across the whole website. So as a new user, I don't have to learn a new UI. Also, it responds at every of my keystroke. I get instant feedback, so it's easy for me as a user to understand why those results are showing. And also an easy way to navigate through the content with contextual filters. Here we use tags. So that's what we're going to build in hopefully 10 minutes. To achieve that, we're going to do what everyone who wants to build an Algolia implementation have to do. That means a three-step process. So first, we're going to import our data. So we're going to push a JSON file through the UI, but of course, we are API first. So in a production use case, you usually use our API clients. Then we're going to configure quickly the search engine through the UI, and then build the search interface. To do so, as I was mentioning, we have API clients for both backend with all the languages currently used in the industry, plus framework integration and CMS integrations. And we have also front-end API clients to build that last part, the UI, which is at the end the most important. And that's a quick reminder to what Tim just mentioned, that today we're going to really focus on that second type of implementation that we call front-end. that doesn't require any backend, since we are at the Serverlessconf. So. And it's also because it's way faster and way quicker to implement. So let's do it. All right. I still need to get my mouse. All right, so to build it, we're going to start here with a bootstrapped up project here. Yeah. So, which is composed of a HTML file. That's a regular HTML project, so I use just a gulp to run the project, to execute and run the server. Then I just have a HTML file with some markup. So we copy-pasted we saved actually the markup from the initial website, and we just gonna inject our own code. And then we have the index.js where we're gonna put all our JavaScript logic. And we also have already some CSS, so we won't do any CSS. Let's assume it has been done already. Otherwise, we'll be spending more than 10 minutes. So we said that the first step is actually to send the data. So here I have my data. I have something like a bit more than 1,000 of records. A record is a JSON object from the Algolia standpoint. So here we see that that record has multiple attributes. One is title, one is tags, so that's an array of tags. We also have the publication date as a timestamp, the description, all the kind of content that I may want to search for or want to be available at display time. Like for example, the image URL or the object URL. I need those, but I won't search within those. So let's upload it. So to do that, I just connect to my Algolia account. So here I connected already. I created a new index called smashing. And what I'm going to do is, as I said, I'm going to just drop that file. So for that, I just select record. I take my file. I push it here. It uploads it. And at the same time it uploads it, it makes it searchable. So I haven't even finished to upload it, but it's already searchable. So not just search is real time, but indexing is real time as well. What matters here is to add some more configuration, because out of the box you can already search for any attribute. But of course I may not want to be looking for content in the offer URL or the image URL. So what I can do is going on the ranking tab, I can specify the different attributes for which I want to search for. So here we'll probably search for those three: title, offer, and description, and you can reorder them by order of priority. This refers to the slide we've seen together. And we also seen that what matters is, of course, textual search, textual relevance, but also business relevance. So what matters to me is get text relevant content which is as fresh as possible. So here I'm gonna use my date, and I would sort it in descending way, so I will get the freshest content first. Once I've done that, I just save. It updates the index and applies my new settings. Here it returns me no results, of course, because I cannot search in the URL anymore. That's expected. But I can search among other attributes. So step 1 is done. Step 2 is done. So let's now focus on step 3, which is where you guys have the freedom to build whatever you want. So to do so, we're going to be using Instancer.js, which is our library, open source library, where just copy-pasting widgets, which we build using the latest technology like React, you're just going to be able to build a UI in less than 50 lines of code. So let's start. So here I have my index. So what I see is I need to initialize the things. So to do so, I go to my credentials tab. I get my details. So I'm going to copy my different keys. Here's the right one. I name my index, so it's called smashing. I just save. And here what we can see is if I refresh, I should already be able to see some stuff. Not yet. So what I need to do, so at that point I've initialized the Instancer.js, so it points directly to my index. what I now need to do is to bind each UI component with some widgets. So to do that, I just go to the documentation and I will add a few widgets. The first one will be the search box. So here, I just take the code, I copy it. So here I just say that actually my name is search bar. So search for articles, autofocus false, stored by, and yeah, and here we need an extra one which is wrap input, but just for display purpose. And then in the second one, the second widget is displaying hits. So a results, when it gets displayed, is called a hit. So I just copy paste that as well. Here I have a markup in my HTML which is called hits container, where I'm going to inject my results. So I specify here the container. I also can define the markup I want to use, so when there is no results, or for each of those items. So here I have something I will do something very basic. So I will just display the title. So we had an attribute called title in the record, but we can see here we have title. So now if I save and I go back to my page, I don't have results. Yeah, I missed the last step. I need to call start. So I need to call search. Let's start. And that will start my search. Boom, I got the first results from my index. So if I search for it, I see that I get relevant results. So that's the first step. Second, and we can of course change anything. Here if I put offer, it will display results with the offer names. So any attribute which is in my record, I can display it. Based on that, what I can do now is I can enrich my template. So at the bottom of the page here, I have all the markup needed to display nicely a hit. So it will display the picture, it will display the offer information, the titles, the descriptions, the tags, and so on. So that's, of course, completely customizable. So it's to the developer responsibility to do it. So I'm just going to target that. Here I'm going to do document.get element by ID. And that should work. Yeah. And automatically, it uses the template here, and it gets the results displayed the way I want. And we see here, there is a JSON response with all the attributes and data I can use. Let's move on. So here we have the dates, we have the comments. What could be nice is actually to make those, to change their display. So we have a way to plug a webhook function. Here we go. So I just need to define here, of course I can display more results. I just define my webhooks, so I can transform the data for each hit. What I do here, I just use moment.js to take a timestamp and convert that to a readable date. And for the comments, I will check if the comments number are greater than 1, and if that's the case, I will display comments with a S or without S. And once we've done that, we should get some transformations. Okay. Here is I need to also change. Here it's called comments. We see that here. I call that comments, and the new one here is called date, and before it was called publish date. So now if I go back to my page, we see that everything has been changed properly. What we may want to do as well is to add some pagination. So we have some extra widgets.
Show the highlight maybe.
Yeah, we have some extra widgets. So I just add them here. So there's one widget, for example, for displaying the stats, displaying how many results, so the time it takes to get the results. There is one for pagination. There is one for creating refinements. Refinements are filters. So I just need to add those ones, and it should work out of the box. Okay. Search stats. So it should be called search stats container. Yep, and here we see that it adds automatically the number of matching results. It adds also the pagination here, so you get that out of the box. So you can paginate across the results, and we should see display the tags, but it doesn't work. So let's move on.
But you need to configure it in the...
Yes, and I need to configure it exactly in the index. So to do that, thanks, Tim. So basically what we need to say is we need to configure the engine on the dashboard. That can be done through the API as well. We need to say that on some attributes, we'd like to turn those into filters, and we call that facet in the search industry. So to do that, I just go to the display tab. I just select tags. Automatically, it will, or tag that name. Yeah. So you can also have nested object. That's really cool. And automatically, the engine will process all the potential values and compute their values. And that's completely contextual to my search query. So once I've done that, if I refresh the page, I should get automatically everything binded with my UI. Last thing, but not the least, when we search, something which is very handy as a user is to get highlighting on the matching strings. And that can be easily added. Just changing my markup here. So by updating the placeholder and just doing highlighted highlight results dot title dot value, and then I take it. So here I'm saying that I'm gonna highlight the title. I can do the same on the description.
And you need the 3 brackets.
And I need the 3 brackets, yes, because otherwise the rendering template doesn't render the value. I mean, it escapes the HTML tags otherwise. So here I have 3, right?
Yeah, but it might not be a highlight result. Check if it's in your other page, if it's singular or plural. I don't remember.
Yes, so here it's highlight result without S. And what we see here is when I type speed, automatically I get an highlight. So here it's in italic, but we could have changed the color. It's just a matter of CSS. Because what you get is you get the string surrounded with EM tags. Yeah, that's pretty much it.
Yeah.
That was for the live coding. So we built something fairly quick. Everything is available on community.algolia.com.
The instance search JS library we talked about is available, but we have also other library for other languages. We have a similar library to do a drop-down instead of a full-page search. We have a lot of different components you can use to building your search UI. And the whole demo we just explained here is also available on GitHub, and you can check it out and redo it yourself. And yeah.
Okay.
Yo.
Thank you very much.
Right
guys.
in time. So thank you.
Time for one question. Does anyone have any questions for these guys? Try 2. You can always come up afterwards anyway. So
my quick question is about the data source. If I put my data in a place like MySQL or MongoDB, and how do you handle the data synchronize? I mean, real-time synchronize, and the search result should show up the data just added to the database. Thank you.
We do have some database connectors that will automatically replicate every update to your database to Algolia. We have one for MongoDB. If you're using Ruby on Rails, for example, we have one directly integrated into Rails. So every time you add, update, delete a record, you can configure it so it's automatically replicated up to Algolia. You have to see Algolia not as your primary database, but a copy of your data that you want to search in.
So whenever you get an update, you push it to Algolia.
And one more question. Yeah, over here.
Yeah, I just wanted to know, with the tags, in your UI, can you point like one tag at a different one? Or if you select a tag, can it search two different ones?
So here we call that a facet.
Yeah.
So in that one, we can only select one value per facet, so one value of tag. But there is a way that we call disjunctive facets, and there is another widget for that where you can select multiple values of a same facet.
And you can configure if you want to, the more tags you select, it restrict the number of results, or it enlarge them like it's and or. And you can configure that. And you can even, we have more advanced query language that you can do a mix of and or different facets.
Yeah, you can do numeric filters, you can do whatever you would do with a regular database most of the time.
Okay. All right, well, thank you, everyone. We're going to have a break for 20 minutes, and then Ben from Cloud Art is going to give us a speech on serverless operations. So a bit longer break, but if you want to speak to the guys.
We have a few community t-shirts. If you want to grab one, just come here, and we'll be happy to give it to them.
And we have an office in Paris and San Francisco, so if you are looking for joining the team, feel free to talk to us. Thank you.
Thanks.
Thank you.